Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now going to go through question number 2, part A, or question number 2, from the specimen paper of the Pure Mathematics P3 Cambridge 9709 syllabus. And this is the, as I said, the specimen paper, which was made before the new specification. And this question here is about binomial expansion. It says expand 1 plus 3x to the power of negative 1/3 in ascending powers of x, up to and including the term in x squared. Okay, so we want up to the term in x squared, simplifying the coefficients. Okay, so now in P1 of Cambridge, we did binomial expansion, but what you should have noticed is that the power to which the bracket was raised was always a positive integer, a positive whole number, right? When we come to P3 of Cambridge and P4 of Edexcel, then you'll notice that the powers that we have to raise, or the brackets are raised to, will be fractions or negative or both. So here you have both negative and a fraction. Okay, so you have something which is not a whole number, not a positive whole number, and neither is it it's not an integer. Basically it's a fraction. So when you have something like this, we can't use the what's called the NCR button on our calculator. So in P2 or P1 for Cambridge, we would use this button, the NCR button, to help us to find some of the coefficients that we need for the expansion. But we cannot do that anymore because the NCR button is really made for whole numbers, positive whole numbers. It's really made for permutations and combinations, which is something which we're going to deal with in this course in Cambridge later on when we do statistics. So it's really meant for whole number kind of situations, positive whole number situations, real life situations. So we cannot use that button. It doesn't work in fractions or negative numbers. So what we're going to do is we're going to use a formula which I've copied here from the formula sheet. Okay, this is the formula from the formula sheet for binomial expansion without using the NCR button. The thing that you have to note here is that it should always have 1 plus something inside the bracket. There should be a 1 here. In this case, it's perfectly fine. There's a 1 here, like there is there. That's fine. Okay, so we don't have to do any modification. If it wasn't a 1 here, for example, if it was 2 plus 3x power minus a third or something like that, all right, then we would have to take out that 2, okay, from the bracket, divide this term by 2, and that 2 would be raised to this power. And then you can have something as 1 plus 3 over 2x to the power of minus 1/3, expand that, and then multiply it by 2 to the power minus 1/3 in the end. Okay, but in this case, we don't have to worry about that. That's perfectly fine because there's a 1 here, all right, because it has to be of this form 1 plus x. If it's any other number here apart from 1, we have to modify it accordingly. All right, that's the first point. So the second point is that the x here is basically the same as the term in this position. Okay, so the x there is the same as this term. So this x is basically the same as this. Okay, the x is the 3x. So the x in the formula is going to be whatever numbers in this place over here. Okay, so when we apply the formula now to this expansion, it says in ascending powers of x. Well, this formula gives us things in ascending powers of x. Okay, so you see x, x squared, x cubed, and so on. So we can take this and apply the formula to our particular situation. So you have 1 plus 3x to the power of negative a half, and we want to go up to x squared, so we want to stop here. You're going to have 1 plus nx. Now n is the power, which is minus 1/3. Sorry, I wrote it as a half. Minus 1/3. Be careful about copying errors like that. Okay, so that's minus 1/3. So you're going to have 1 plus nx, so 1 plus minus 1/3 times x. Now x is this term, the whole of this term, which is 3x. Okay, so that's the first two terms, and then we have one more to go, plus n times n minus 1. So n is minus 1/3, and n minus 1 is minus 1/3 minus 1. So if you do minus 1/3 minus 1, which is minus 3 over 3, you get minus 4 over 3. Over 2 factorial. Now 2 factorial means 2 times 1. 3 factorial means 3 times 2 times 1. 4 factorial, 4 times 3 times 2 times 1. okay, times x squared. Now x, remember, is our 3x there, squared plus, and then we stop there. Why? Because the question tells us up to and including the term in x squared. They want us to give the terms here, so we're going to now simplify this. All right, so you have 1, that's fine, and you got minus x, because you have minus the third times 3 is 1, so it's going to give negative x. And let's try to sort this out. You're going to have here negative times negative, okay, which is going to give you positive times something positive, so it's going to be positive. The next term is going to be a positive term, and then we can try to cancel out what cancels out here. The 4 up here will cancel with this 2, so you're going to be left here with, that's going to be 2 over 9 times, and this is going to be 3x squared. It gives you 9x squared. 3x all squared, 9x squared. It's always good to write, I like to write this out separately, because sometimes you start cancelling this number with these numbers sometimes, and you forget that it has to be squared first. So I like to do this part separately and this part separately, and then cancel out. As you can see here, they will actually cancel out, and you're left with the 2, yeah, you're left with 1 minus x plus 2x squared, and that's as far as we need to go in this question. 1 minus x plus 2x squared, and that's the answer for 2 part A, and that's the 3 marks there. All right, so they want us to give the term. Sometimes I say find the coefficient of x squared, for example. In that case, you would just write 2. So the coefficient of x squared is 2. You wouldn't say the coefficient of x squared is 2x squared. Just write the coefficient of x squared is 2 if they ask that. But here they want the whole term. They want to see the expansion up to and including the term in x squared in ascending powers of x, and that's exactly what we have here. So there's the answer to part A. Now for part B, it says state the set of values of x for which the expansion is valid. I'm going to go back up here and have a look at this. Now many people just memorize how to deal with this question, and they will take this term, which is 3x, and they'll say its magnitude has to be less than 1, which means that 3 times the magnitude of x has to be less than 1, which means the magnitude of x has to be less than a third, and that's perfectly fine. Okay, so that means x must be between minus 1/3 and 1/3. Okay, so that's the answer to part 2 of the question, which I'm going to write down there. But I want you to understand why that is the case, right? Because this expansion here, as we can see from this, if we continue on and on and on, this will never end, okay? For example, if it was 1 plus 3x, say to the power of 3, you would have 1 plus 3 times 3x, 1 plus nx, plus then you have n, which is going to be 3 times n minus 1, which is 2, times 3x all squared over 2 factorial. If you carried it on, okay, I'm showing you what happens when you have a positive integer here. You have 3 times 2 times 1, n times n minus 1 times n minus 2 over 3 factorial, times 3x, and that's going to be cubed. And then if you carry on, the next term is going to be 3 times 2 times 1 times 0, okay, times 3x to the power of 4 over 4 factorial. Well, this term is going to become 0. That's why it ends there. And there's going to be a 0 in every other term if you try to do it. Like, say, the next term, you have 3 times 2 times 1 times 0 times minus 1 over 5 factorial times 3x all to the power 5. Because of that 0 there, it's going to be cancelled out. So it's a finite expansion. It stops at the x cubed term, okay, if it's got a positive integer here. But if this power is negative or fractional, you will never get to 0. Okay, so even, for example, if it was a half, you would have 3 times a half. So you have 3 times the x value. Then you'll have a half times the x value. Then you'll have a half times 1 minus a half minus 1. So you'll have a half times minus a half. Okay, and then a half times minus a half times minus 3 over 2. You skip the 0, so there'll be a 0 there won't be any 0 in any of the terms. So it's going to be expansion that goes on forever and ever. It will never end. It's called an infinite expansion. So if you have a negative integer, or you have a fractional power, or both in this case, then you'll end up with what's called an infinite expansion. It goes on forever and ever and ever. All right, so I can never say that this is going to be the same as that. Okay, it's going to be approximately the same as that. Okay, it will continue on forever and ever. It won't stop. Okay, so how is that going to affect this question? It says for which the expansion is valid. Well, if the value of this term here, which goes inside this bracket here, and if you go further, it's going to be cubed and raised to the power of 4 and the raised to the power of 5 and the raised to the power of 6. If the value of that term is greater than 1, then the value of this expansion will continue to increase, get bigger and bigger and bigger and bigger. For example, if the value of this is 2, if 3x, if this thing that you put in here, if its value was 2, okay, then it's going to be 2 here, then it's going to be 4, then it's going to be cubed 8, then it's going to be raised to about 460, it's going to be raised to about 10, it's going to be 1024. The value of this expansion will continue increasing and increasing and increasing, and you won't be able to say, okay, I can stop here and say this is almost the same as that. It's not a valid expansion for that value. But if the value of what's inside here is less than 1, for example, a half, then when you square a half, it becomes smaller, it becomes a quarter. When you cube a half, it becomes even smaller, it becomes 1/8. When you raise it to the power of 10, it becomes 1/1024. It ends up becoming so small that the subsequent terms don't make a difference to the value of the expansion. So this would be only a valid expansion if the magnitude of this term, once you have a 1 plus here, this term here, the 3x in this case, is less than 1. So it doesn't matter if it's positive or negative, but its magnitude must be less than 1. That is what we have to solve this inequality, right? And that will be true. As I mentioned, this is the same as saying 3 times the modulus of x is less than 1, which is the same as saying the modulus of x is less than a third, which, if you want to write it as a inequality, means x should be between minus 1/3 and 1/3. I'm sure that both of these will be acceptable. Both of these answers will be acceptable. All right. So there's the answer to part B. I hope I want to explain why that is the case. I hope that was clear in this expansion. The reason why the magnitude of this has to always be less than 1 for this to be considered a valid expansion. Okay, because we can't just if this value here is greater than 1, we can't just stop here and say this is the same as that. This is almost the same as that. Okay, we can't say that because the next terms after that are going to get so huge that we can't say that it's the same. It won't be valid. But if the value of this is less than 1, the subsequent terms are going to get so small that they won't make a difference to the value of the expansion. So we can say this is approximately the same as this, and that's fine. Okay, so I hope that was clear with a little bit of explanation, because a lot of students, they don't understand why, or they just memorize, all right, I know I have to take this and find the modulus of this being less than 1, and then you get the answer without understanding why. And it's always good to understand why. All right, so there's the answer to question 2 of this specimen paper. Other questions from this particular paper can be found in the playlist that will appear in this part of the screen at the end of the video. Other questions from the topic of binomial expansion from P3 of Cambridge can be found in the playlist over here. I'll also include here a playlist from my P4 binomial expansion from edXL, as I've just started doing the Cambridge papers, so you can see other questions which will be very similar in terms of same concept from edXL, so you can see other examples of this topic, and you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.